In this video, we will look at how we can predict whether a precipitate will form or not during a double displacement reaction. So recall that double displacement reactions involve the exchange of cations between two ionic compounds. And in general, they can be represented this way. So you can see in this reaction, the A and the B have switched partners. In this example, sodium chloride reacts with silver nitrate to make silver chloride and sodium nitrate. So you can see that the silver and the sodium have switched places. If you take two aqueous ionic compounds and mix them together, that doesn't guarantee that a double displacement reaction will occur. You can tell that a double displacement reaction has occurred if one of the following three things happens. So first, if a precipitate is formed, which means a solid compound. If water is produced, or if a gas is produced. In this video, we're just going to be looking at reactions where a precipitate is formed. So let's look at what's happening as we carry out this reaction. So each aqueous solution that we're mixing, so in this case lithium chloride and lead 2 nitrate, so that solution has its ions just floating around freely. Now I realize they don't look all that free there, but they're just floating in the solution. And they get dumped into the beaker to react together. And now all the ions are floating in one combined solution. So unless two of those ions react together and come out of the solution, nothing has really changed, right? Before the reaction, we had lithium and chloride ions floating and lead 2 and nitrate ions floating. And after we mix them, that's still what we've got. So in order for a reaction to happen, or in order for us to see anything, two of those ions have to come together and have a low solubility. So they come out of the solution. And with this reaction, that does happen. The lead and the chloride ions, when they come together, they would rather be joined together than be interacting with the water. So they come out of the solution and settle to the bottom as a lead 2 chloride precipitate. So in this case, a reaction has occurred. And this happens because lead 2 chloride has a low solubility in water. So as a summary of that, a precipitate is a solid that separates from solution as the result of a chemical reaction. If both potential products are soluble in water, or aqueous, then no reaction has actually occurred. So to determine if a product forms a precipitate in water, you consult the solubility rules. And if it does form a precipitate, that means a reaction has occurred. So let's look at some examples. So we're going to determine the products that form when, for the first one, magnesium chloride reacts with potassium hydroxide. And if a reaction occurs, we're going to write a balanced chemical equation. So first we have to figure out the formulas for magnesium chloride and potassium hydroxide. So these are ionic compounds, so we take the ions of magnesium and chlorine, cross them over to get magnesium chloride MgCl2. And double displacement reactions happen in solution, right? So your reactants are going to be aqueous. So then we have potassium hydroxide. So there's our two ions. We cross over the charges. So we get plus KOH, again aqueous. So now we have to carry out the double displacement. So we switch the partners of the cations. So magnesium is now with the hydroxide ion. So we cross those over. We get MgOH2. And the potassium is now with chlorine. Cross those over. We get KCl. Now we need to check the solubility rules to see if either of those two products has a low solubility and will form a precipitate. And when you do that, you discover that magnesium hydroxide has a low solubility and so forms the precipitate and gets denoted as a solid in the reaction. Potassium chloride is soluble in water, so it remains aqueous. Then we just need to balance this equation, which we can do by adding a couple 2's. Now if we look at another reaction, calcium iodide reacts with sodium nitrate. So we have calcium ion, Ca2+, and the iodine ion, I-, cross over the charges to get CaI2, sodium and nitrate, sodium nitrate. Now we're going to switch partners. So the calcium is now going to be with the nitrate, giving us CaNO3, and the sodium is with the iodine, giving us sodium iodide. Now we'll check the solubility rules to see whether calcium nitrate is soluble or has a low solubility. Same for sodium iodide. And when we do that, we discover that they're both soluble. So everything is just soluble, which means that no reaction has occurred. Okay, let's look at another couple examples. Lithium acetate reacts with iron 3 fluoride. So first we figure out the formulas for our reactants. Lithium ion and the acetate ion. Cross them over. LiCH3COO aqueous. And then we have iron 3 fluoride. Cross them over. FeF3 aqueous. So then they're going to switch partners, and rather than write it all out, you can sometimes consult the solubility table to figure out if it's going to happen first. So you check lithium fluoride, and then you check iron 3 acetate. And when you do that, you figure out that they're both soluble, which means there's no reaction in this case. In our final example, we have calcium bromide reacting with sodium sulfate. So there's calcium and bromine ions. Cross them over. CaBr2 aqueous plus Na2SO4 aqueous. Then they're going to swap partners. So that would be calcium sulfate and sodium bromide. And if you did a check of that before you write it all out, you would find that one of those is a precipitate. So we'll continue. Calcium sulfate, cross them over, get CaSO4, sodium bromide, and NaBr. Then we check the solubility table, and calcium sulfate has a low solubility, so it forms a precipitate, and sodium bromide is soluble or aqueous. So this reaction has occurred, and then the last thing we have to do is balance, which we can do by adding a 2 right in front of the sodium bromide.